My name is Jessica Hoffmann, and I'm very happy to present here one of our new innovative products for floor coating and self-leveling applications. This presentation will include some facts about the new product and the way we did to make that UV stable, as well as some formulation advice. So here we can already see the biggest difference we have with the new product compared to old products. As you can see, it is crystal clear. This is actually very unusual for a castor oil-based polyol. Normally, they are always very yellowish or have like this slightly orange tone, what makes them difficult to formulate potting resins, for example. Some key facts about the product. It is pale white, has a viscosity around 1,500 MPa, and an OH content of 6.15%. And that was one of the biggest innovations we did here, that we tried to create a resin which is relatively hard with a low demand of isocyanate, because the isocyanate part is normally in aliphatic systems the biggest impact on cost. So the goals we wanted to achieve was we wanted to have a 100% VOC-free resin, which survives 1,000 hours QUV. We tested here QUV-A as well as QUV-B. Additional to that, we wanted to keep high chemical resistance. And of course, we wanted to have that pale and clear and whitish appearance. Compared to standard polyols, we have the same kind of abrasion resistance. And of course, we have still, because it's still a castor oil, a very, very high hydrophobic character. Here we can see how normally formulations look, which are used for stone carpets. We used here a marble kind of flake and tested then the samples in the QUV. You can see here we have the standard before exposure and then the other samples afterwards. And even after 24 hours of QUV, we already see a color change. That color change is caused because castor oils normally are not very heat stable, and the heat which is developed in a QUV machine is relatively high. That is one of the big issues we're always facing when we develop a product like this, that the reality is quite different than the QUV machines are. So where is this UV yellowing coming from? As you can see, we still have some double bonds in castor oils. They cause the yellowing. But additional to that, castor oil is a renewable resource based on a natural oil. So that means we have a lot of side effects over the acid, which is still in the refined oil, and over the colorants, which are coming from the shell of the bean into the system. And that is also the reason why they are normally limited on saponification stability. 1055, because it is a super cleaned castor oil used for the production of the polyol, doesn't have that side effect. So it's much more saponification stable as well as UV stable. Here we can see an example for the color, and I would like to also show you the sample by itself. This is cross-linked with an aliphatic isocyanate, and you can see it is pale in color and comparable to what we have on the standard, where we have hydrogenated epoxies, which are the, at the moment, only alternative in terms of pricing and performance. In the middle, we see the market standard. That is the standard castor oil-based polyol, which was basically highly over-cross-linked. This was how we did that in the past with the aliphatic isocyanate in order to create hardness, because normally we always have that issue. MDI makes the system quite hard. The polyol has to make the system soft in order to balance that behavior. So when we have aliphatic hardness, we have already a soft hardness. So that means the polyol has to come up with a performance of hardness and tensile strength. So we did that over the adjustment of the polyol and the different molecular weight, and exposed these 3 samples to 1,000 hours QUV. And as you can see, we have a tremendous color difference. The market standard also has very dark sides. That is coming from the yellowing under the very, very hot temperatures in a QEV machine. That means 1055 is also UV stable, plus it is thermo stable. So some hard facts about the physical properties of this polyol. You can see the table resistance is comparable to what we know from the market, 35 milligram. For those which are not so familiar with that measurement, 10 milligram is at the moment one of the best resins on the market. So 35 is quite good for a polyol like that. The elongation is between 80 and 120%, because here we have a big impact from the isocyanates. Depending on your isocyanates, you have an elongation from 80 to 120%. The shore A and the shore D, we also measured under higher temperatures, because normally what you can see is that castor oil-based polyols, they have a softening effect under higher temperatures. So when we developed that resin, we thought about countries like Dubai or Malaysia, where we have in general higher temperatures, so we need to maintain a high surface hardness even under higher temperatures. The gloss is a medium gloss, typically for that kind of application. And you can see it, if you compare it to epoxy at the beginning, epoxy will always be a little bit more glossy than that resin. But it looks applied like a really, really high gloss sample. Coming to the hardness, here what is very important is the incorporation and incompatibility with different hardness. So there we can say, as higher the molecular weight, as more side effects you have on the mixing properties, which is especially in flooring and construction applications a really high challenge, because there we have just physical mixing, we have no dissolver or highly machines, and there we can see a big impact. So what you can see on the picture is like kind of stripes plus foam. This is basically isocyanate penetrating to the surface because it isn't full compatible with the polyol. And that can cause various kind of side effects. So some people see that as fish eyes or think it's a defoamer problem, but it is a problem between the polyol and the isocyanate. As you can see, we tested the full range of aliphatic isocyanates for self-leveling floor coatings as well as for potting resins. And you can see the 1055 is relatively compatible compared to our old technology. So we have here a little bit more compatible hardness. And this we made because the molecular weight is a little bit lower than former products, in order to have really an easy and nice blending in a short time, and to have at the end, at the application side, a perfect surface. So let's have a look on the impact on isocyanates. So the first look, if we look at shore A hardness after 7 days, we don't see a big difference no matter what kind of technology we are using. Doesn't matter if it is trimers or biorets, they're all relatively hard. The samples are also tested purely, so there is no fillers inside. Otherwise, there would be, I would say, around 10% harder than the results we have here. So what you can see is that by far the 2840 the 2838 is really hard, comparable to the 3200. But if we look now at the shore D hardness, we see that the 3900 is much better than the 3200, even though the incompatibility is a little bit higher here. And now the main difference comes if we look at elongation and tensile strength. And that is what a lot of people who work the first time with this polyol recognize. They think with their trimer, it is relatively soft, but what we see is that balance between tensile strength and hardness. So for example, the 2838, a lot of people think it's much harder, because the tensile strength is much higher, because you cannot bend the sample. But at the end, on a floor coating, you would not recognize that differences. You would recognize that on a roofing, where you really need a little bit more elongation and a little bit more tensile to overcome higher temperature changes. So here we see the big differences. We looked at the product very closely, and what we can see is that we think, because the 2838 is so extremely compatible and has IPDI, that therefore the tensile strength is very fastly activated and gives us that really fast performance. Of course, when we work with aliphatic systems and 100% systems, the next big question comes, what is about the catalyzer? Especially in Europe, we have a big deal with metal-free, heavy metal-free catalyzers. We try to overcome that. So in Alberdingk, we did a lot of evaluation. So if you work with a certain catalyzer and you would like to know if that works in the sample, please let us know. We can supply you all the information at our booth. But what we can say generally is that the response is comparable to older technologies. That means you can work still with DBTL if you want to. You can work with DOTL. We have the same kind of pot life. We have the same kind of handling and leveling properties. And what is really nice, we can also work with a lot of bismuth catalyzers in order to get a nice pot life and hardness development. What we also evaluated was the combination with different copolyols. We know copper is very familiar with the most. Here as well, we have a high compatibility with the standard coppers. With the new highly functional coppers, we have to see it is really depending on the amount. Let's say you can work with 5 or 6% copper, but if you would like to incorporate more, you probably see turbidity. This will be an issue in clear systems, but not in pigmented systems. So you will not see any surface difficulties. You can also combine that with our polyols. They are very compatible with each other. There, I have to say, they are mainly made for aromatic systems. So if you use them in combination, you might see some yellowing again. But you can get a really, really nice elongation. So you can push the elongation up to 180%. Easily by combining it with a product like ALBODUR 942. All right, so here the key facts again. 1055 is a UV stable castor oil based polyols, can be very easy formulated. I also have some samples with me if you would like to take a quick look. Otherwise, I would be more than happy to see you at our booth and show you more results we achieved with that polyol. So thank you very much for your attention. Do you have any questions?